Imagine a rabbit and a hunter. The rabbit hides behind one of several bushes, and the hunter can shoot at them. Each time the hunter fires, the rabbit gets scared and has to move to an adjacent bush. However, the rabbit is invisible, so the hunter has no idea where it goes. This process repeats. The hunter shoots, the rabbit moves, the hunter shoots, the rabbit moves, until eventually the hunter hits the bush where the rabbit is hiding. But can the hunter always hit the rabbit no matter how it moves? Keep in mind, the hunter doesn't know where the rabbit starts or where it moves to. One way to think about this is that the hunter must announce the strategy in advance, and the rabbit can use this information to plan its moves. Let's look at a simple example with 3 bushes. In this case, the hunter can simply decide to shoot at the middle twice. If the rabbit starts in the middle, the hunter wins immediately. Otherwise, after the first shot, the rabbit will be forced to move into the middle, where the hunter will hit it on the second round. Also, there's no way to guarantee a hit with only one shot, which means that the best strategy in this case requires 2 shots. But what about 4 or 5 bushes? And can you always find an optimal strategy for the general case of n bushes? It turns out that there is a strategy for the hunter that requires at most 2n-4 shots. But what does the strategy looks like, and how can we prove that it's truly optimal? For this, let's consider an example with 6 bushes. However, I would like to look at this problem from a different angle and organize it into a table. In this table, each row represents a possible position of the rabbit, while each column represents a round of the game. The rabbit starts in the first column and tries to move to the last column. Since the rabbit must move to an adjacent bush each round, it can only move diagonally. Meanwhile, the hunter picks one bush to shoot at in each round, which means that he can place a single axe in each column. Once the hunter's shots are marked, the rabbit begins at the first column and must navigate through the table, always avoiding the hunter's shots. If the rabbit makes it to the last column without getting hit, it wins. So the big question is, how can we place the axe so that the rabbit never makes it to the other side? We can place the hunter's shots in the following diagonal way by first shooting at position 2 through n-1 and then moving back from n-1 to 2. To see why this works, let's start by coloring the tiles in a chessboard-like manner. Notice that the rabbit can never change its color since it can only move diagonally. If it starts on a blue tile, it must stay on a blue tile, and if it starts on a green tile, it must stay on a green tile. Suppose the rabbit starts on a blue tile. In this case, it is confined to the lower triangular region of the board as it cannot cross the diagonal line of shots. Eventually, it will be forced into a corner where it has no choice but to run into one of the hunter's shots. On the other hand, if the rabbit starts on a green tile, it's completely safe for the first half of the game. However, the moment it enters the second half of the board, the situation becomes identical to the previous case. Again, it will be trapped by the diagonal wall of shots and eventually forced into a corner, leading to a hit. Since this works in general, we conclude that the hunter can always win using at most 2n-4 shots, as each diagonal contains n-2 many shots. But why is this strategy optimal? Why isn't there a way to win with just 2n-5 shots? Is there really no better way to solve this problem? To show that any strategy using only 2n-5 shots fails, we will focus on the inner rows, meaning we will ignore the 2 outermost rows. There are exactly n-2 such rows. However, each row has 2 possible colors, so in total there are 2n-4 row color pairs. Now, if the hunter only has 2n-5 shots, there must be at least one row color pair that remains untouched, simply because the hunter doesn't have enough shots to cover them all. For example, here the third row with the color blue is never hit, and here the 5th row with the color green is never hit. We can use this fact to construct a winning strategy for the rabbit. Instead of looking at the entire board, we will only focus on a specific row and its neighboring rows. The rabbit starts in this row. And now here's the key observation. Since the hunter can only fire 1 shot per round, he can only cover at most one of the 2 neighboring rows, meaning the rabbit can simply pick the tile that is not covered by the hunter. This is the reason why we only considered inner rows. In the next round, the rabbit simply moves back to the 5th row since it's free by assumption, and now we can simply repeat the whole process. The hunter can choose at most 1 neighbor, the rabbit moves to the free neighbor, the rabbit moves to the middle again, and so on. This continues until it hits the end where it wins. This strategy also works in different cases. By continuously dancing around the middle, the rabbit can always find a way to evade the hunter. This proves that 2n-5 shots are not enough, and therefore our strategy using 2n-4 shots is optimal. Pretty neat. Again, I got this riddle from the Riddler.